Good morning friends, this is Srinivas. Today video about sp3d2 hybridization. Okay friends, sp3d2 hybridization. Okay, in sp3 hybridization intermix atomic orbitals. In sp3 hybridization intermix the pure atomic orbitals, one s orbital, three p orbitals and two d orbitals are intermix each other. Okay, now 1 plus 3 4 and 4 plus 2 6 atomic orbitals are involved in this hybridization. In the sp3d hybridization 6 atomic orbitals are 1 3 4 4 plus 2 6 atomic orbitals are involved in sp3 hybridization. Now 6 hybridized orbitals are formed. 6 hybridized orbitals are formed. 6 sp3d2 hybrid 6 sp3d2 hybridized orbitals are formed. Okay, so 1 s orbital, 3 p orbitals, 2 d orbitals are involved in the hybridization. Now these 6 atomic orbitals are intermix each other to form identical hybridized orbitals, 6 sp3d2 orbitals. Okay, this is the sp3d hybridization. This is a sp3d hybridization. In the sp3d hybridization, s character 16.7% and p character 50.1% and d character 33.4%. Okay now friends, here look at all of you. In the sp3d hybridization, s character is 16.7%, p character is 50.1%, d character is 33.4%. okay, it means here 3 p orbitals are there, 3 p orbitals here, 3 p orbitals, p plus p plus p plus p. Okay, here also 3px. okay, here also 2 d orbitals are there, 2 d orbitals are there. Okay, look at here, 1 s orbital, 1 s orbital, 1 s orbital, like this. 1 s orbital, 1 s orbital 16.7%. okay, 3 p orbitals, one each one 17.7, 16.7, 16.7. It is also 16.7. It is also 16.7. Like this percentage. Okay, the energy also, the shape, the bond angles, bond lengths, all are shared equally. That's why hybridization is more important in chemical bonding also. Okay, that's why in chemical bonding all molecules having the same bond length, same bond energy is also there. in your bond, in your molecule, all bonds are same energy, all bonds are same bond length, between the all bonds the bond angle also same, because of the sp3d hybridization. Sorry, because of the hybridization. Okay friends, because of the hybridization only. Okay, now here the bond angles between any two hybridized orbitals. Here the bond angles between any two sp3d2 hybridized orbitals. Okay, the bond angle between any two sp3d2 like any two sp3d2 hybridized orbitals, the bond angles are 90 degrees and 180 degrees also there. Two bond angles are there, 90 degrees and 180 degrees. Okay, some are perpendicular to each other, some are linear each other. okay friends, so once look at here all of you, this is the bond angle, and also what is the sp3d2 shape? This is bond angles. These are bond angles. These are bond angles. Okay. Next, shape. What is the shape of sp3d2? Shape of sp3d2 is octahydral shape. Octahydral. Octahydral shape. Okay. Once look at all of you. Around the central atom, any one central atom is there. Any one central atom is there. Around central atom. Around central atom. Around central atom. Six sp3d2 hybridized orbitals are there. This is also sp3d2. It is also sp3d2. This is also sp3d2. This is also sp3d2. This is also sp3d2. This is also sp3d2. Okay, these all are look like a hexagon, like this. Okay, each orbital is also sp3d2 orbital. It is also sp3d2. 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 Okay, these all are sp3d2. Okay, now the bond angle between these two are these two 90 degrees. The bond angle between these two 90 degrees. Now the bond angle between here 180 degrees. 180 degrees. Okay. Lesson 1, sir, all of you. The bond angles once I explained clearly. Bond angle axial, sp3d2 plus equatorial sp3d2 is 90 degrees bond angle. Okay, now axial sp3d2 plus axial sp3d2. The bond angle is 180 degrees. Now, and equatorial sp3d2 plus equatorial sp3d orbital 180 degrees. Okay, these 3 points once look at. Okay, these 3 points all of you once look at. Okay, the bond angle between axial and equatorial 80 degrees, 90 degrees, axial and equatorial 180 degrees. Okay, now which are axial? This is axial. Okay, axial. This is also axial. Equatorial. It is also equatorial. Okay, any two equatorial orbitals bond angle is 180 degrees. Any two axials is 180 degrees, but the equatorial and axial bond angle is 90 degrees. Okay, friends. Now, example. What is the example for sp3 hybridization? Example is SF6. Best example is SF sulfur hexafluoride. Okay, in this central atom is sulfur. Central atom is sulfur. Sulfur atomic number 16. Sulfur atomic number 16. Its electron configuration neon 3s2, 3p4, 3d0. It's a ground state electron configuration. It is ground state electronic configuration. Okay, now how to take excited state electron configuration. Neon 3s2. Now we have to take excited state. Neon 3s2, 3s1, 3px1, 3py1, 3pz1, 3d x square minus y square 1, 3d z square 1, 3d z square 1. Okay, now 1 s orbital, 3 p orbitals, 2 d orbitals in this. Okay, it means 1 3s orbital, 3px, 3py, 3pz orbitals, 2d x square y square, 3z square orbitals are there. Okay, now in the SF6 sulfur undergoes SF6 sulfur undergoes sp3d2 hybridization. Now around the sulfur 6 sp3d2 orbitals are there. Around the sulfur 6 sp3d2 orbitals are there. Okay, for this sp3d2 orbitals of sulfur now are bonded with fluorine. Fluorine bonded with fluorine. Okay, fluorine atomic number is 9. Fluorine atomic number is 9. Electron configuration 1s2, 2s2, 2p, x2, 2p, y2, 2p, z1. Now this 2p z1 orbital is bonded with sulfur sp3d2 orbital. Okay, thus 2p z orbital look like this. 2p z orbital with one electron. 2p z orbital. Okay, now these 2p z orbitals, how many sulfurs are there? How many fluorines are there? 6 fluorines are there. Now 6 2p z orbitals of fluorine bonded with 6 sp3d2 orbitals of sulfur. Okay, na friends. Now we have to draw the perfect structure. Okay, na? Okay, friends. We have to draw the perfect structure of SF6. Now, okay, look, central atom sulfur, central atom sulfur. Around the central atom sulfur, now we will draw sp3d2 orbitals of sulfur. 6 sp3 orbitals like this. These are 6 sp3d2 orbitals. These 6 sp3d orbitals, 6 2p z orbitals are bonded. Like this. Okay, these all are sp3d2 2pz, sp3d2 2pz, sp3d2 2pz, sp3d2 2pz, 2pz sp3d2. Okay, 2pz sp3d2. Okay, the bond between these two sigma bond, these two also 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 sigma bond. Now around sulfur 6 sp3d2 2pz sigma bonds are there. Sigma bonds. Okay, these 6 sigma bonds are spreaded in 6 directions. In 6 directions around the sulfur, like octahydral, like octahydral, like octahydral, like octahedral structure, like octahedral structure around the sulfur. These 6 sp3d2 2pz sigma bond orbitals are spreaded around sulfur like octahedral structure. Now this octahedral structure simply drawn like this: fluorine, 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 fluorine. Okay, okay. These are 6 sp3d2 2pz orbitals SF6. Okay, this is called octahedral structure. Octahedral octahydral structure of SF6. Okay, this is the sp3d2 hybridation, its example. Here bond angle is 90 degrees. Okay, now here bond angle is 180 degrees. 180 degrees. Okay, now friends, this shape is octahydral. This shape is octahydral. Okay, now friends, thank you. Please subscribe my channel and make a comment and give one like also for better encouragement to me make more videos. Thank you, one and all.